Hello everyone, in this video we are going to use R to build the prediction tree and then use this tree to score the new cases. So in this video we are going to use historical data from 500 bank customers to develop a prediction model for predicting a customer's account balance. We also want to assess the performance of the regression tree and then score 20 new customers. So for that reason, first we are going to import the data and save it as my data. Before doing that, you need to make sure that you set your working directory, and working directory is where you have your data set. So after you set the working directory, you can type my data is equal to read.csv, and in the quotation mark and in the parentheses the title of the data and then extension, and then you run. On the environments pane, you can see that my data with 500 observations and 4 variables. You can click and see. So age, sex, income, and balance. So we want to predict the balance of the customer given age, sex, and income. And next you need to install the required packages. The required packages for prediction tree are caret, rpart, rpart.plot, and forecast. All these packages are now inactive because I use the hashtag sign. The reason I do is because I have already installed these packages. If you don't, you can activate them by just deleting the hashtag sign. And after you install the packages, you need to activate them by using library function. And next, we are going to partition the data. By setting the random seed to 1, I will generate the same partitions all the time. As the construction of a decision tree is a data-driven process and can benefit from a large training set, we use the create data partition function to randomly allocate 70% of data into training set and 30% into the validation set. Therefore, let's start and type set.seed1 because I always want the same partition every time I run this code. And then I create an object called myIndex is equal to create data partition is going to partition the data for you, and we are using my data, and our target variable is balance, and we use p is equal to 0.7 and then list is equal to false. And let's run this code. For train set, I'm going to use my index. For validation set, I'm going to use my data, but this time I will select negative my index, everything other than index. And then let's run these 2 lines, and you have train set 352 observations and validation set 148 observations. We use the rpart function to generate the default classification tree labeled default_tree. Within the rpart function, we specify the model structure, data source, and method. The method is going to be ANOVA, and this option tells the function to build a regression tree to estimate a numerical target value. To view the details of the default tree, we use the summary function. To ensure consistency of the cross-validation results, we use the set.seed function to fix the random seed to 1. So let's start with first set.seed1, and then next we create our default tree is equal to, we use rpart, and in the parentheses our target variable is balance, and then we use all the predictor variables. Therefore we have the dot, and data is going to be the train set. We use train set to build the model, and then method is going to be ANOVA as I said before, and finally we close the parentheses. Let's run this, and we can use the summary function, summary default tree, and control enter. So you can see the details of the default tree on the console pane. To view the regression tree visually, we use the PRP function. The type option is set equal to 1 so that all nodes except the leaf nodes are labeled in the tree diagram. The extra option is set equal to 1 so that the number of observations that fall into each node are displayed. The under option is set equal to true in order to put the number of cases under each decision node in the diagram. So in order to visualize the tree, we are going to use PRP function, and the tree is default tree. So we type our tree first, and then we choose type is equal to 1. As I explained, type is equal to 1 is chosen so that all nodes except the leaf nodes are labeled in the tree diagram. And next we will choose extra is equal to 1. The reason is because the number of observations that fall into each node are displayed with choosing extra is equal to 1 option. And under is equal to true. And this option is chosen in order to put the number of cases under each decision node in the diagram. So our tree is ready and we can control and enter. So on the plots pane, you can see the default regression tree for predicting average balance. As we discussed earlier in the previous videos, to find the optimal decision tree, a common practice is to grow the full tree and then prune it to a less complex tree based on the prediction errors produced by the cross-validation process of the rpart function. By identifying the value of complexity parameter, which is CP, associated with the smallest cross-validated prediction error, we can create the minimum error tree. Next, I will show the pruning process to optimize the complexity of the tree. Let's first grow the full tree by using the rpart function. So let's first set seed is equal to 1, and then we title our full tree as full underscore tree is equal to rpart, and open the parentheses, first our target variable and then all predictor variables, and data is equal to train set, and method is equal to ANOVA as explained before. And here we choose CP is equal to 0, min split is equal to 2, and min bucket is equal to 1. So we set the option CP equal to 0, min split equal to 2, and min bucket equal to 1. The reason is because these settings ensure that the largest possible tree will be produced. Now let's run this. And next we are going to use PRP function to plot the full tree. PRP, open the parentheses, this is our tree, full tree. Type is equal to 1, extra is equal to 1, and under is equal to true. And now we are going to control enter. So the full tree in this case is very complex, as you see on the plots pane. In the next video, we are going to learn how to prune this tree and evaluate the performance statistics, and finally we are going to score new customers. Thank you for watching this video.